Hi, I'm going to be doing a brief description on Arabic mathematics. Um, I'm just going to give you a quick overview. Several cultures have influenced the advancement of mathematics through the years, causing controversies and breakthrough discoveries over time. Although the Greek and the European civilizations have been accredited with majority of the contributions and innovations associated with mathematics, the Hindu Arabic culture has put forth some of the greatest contributions to the subject. Um, it's believed that mathematicians were not given the deserved credit or the acknowledgments in the history of mathematics due to Western civilizations taking their known work and copying it as their own. Some of the Hindu contributions to mathematics include areas of arithmetic, geometry, algebra, mathematical logic, general mathematics, trigonometry, and the development of the currently wide used Hindu Arabic number system. So I hope you enjoy what you're about to see, and thanks for tuning in. Hello, my name is Lene Majet, and I will be talking to you about Arabic mathematics and their contributions to mathematics. Several cultures have influenced the advancement of mathematics. The Arabic culture has put forth some of the greatest contributions to this subject. It is believed that the culture wasn't given the deserved credit because Western civilizations took credit for their accomplishments, claiming it as their own. There are several great Arabic mathematicians who influenced the involvement of mathematics over the years. Al-Khwarizmi, he could be acknowledged as the father of algebra. The word algorithm is actually derived from his name. He also wrote a book, and I really can't pronounce the word, but it means the compendious book of calculation by completion and balancing. He also wrote another book, and the translation of that name is Algorithmy on the Numbers of the Indians. This book contained his explanation of the use of the number zero. And before this time, zero and negative numbers were not really accepted along with infinity. Here we have a picture of Al-Khwarizmi. He encouraged the use of Arabic number system and presented it to the Greeks and the Western civilizations. By doing this, he kind of advanced us to where we are today because the Arabic number system is the most widely used number system used today, and is what we use currently in the United States. The evolution from geometry to algebra can be seen in Al-Khwarizmi's solution of the quadratic equation. And that is Al-Khwarizmi. Now we have Brahmagupta. He was influential in different areas of mathematics, such as algebra, arithmetic, geometry, trigonometry, and Diophantine equations. Known to express the theory of zero. Again, like I said before, zero wasn't really accepted during those times, but he expressed the theory of the number zero, something not being there, but being used as a counting number. He wrote a book called Brahma Pusiddhanata. I'm sure I really messed it up, which is the first book to mention zero as a usable number. Brahmagupta set the foundation of using zero and the usage of zero with positive and negative numbers. So it was like the existence of numbers not being there. It was kind of hard for them to see two negative apples versus seeing two positive apples. So he brought that to everybody's attention. He also expressed the quadratic formula in written words, which is to the absolute number multiplied by 4 times the coefficient of the square. Add the square of the coefficient of the middle term, the square root of the same, less the coefficient of the middle term, being divided by twice the coefficient of the square is the value. Which is pretty much what I just said right here, just in words. Just showing us that X had a value. And that is Brahmagupta. I'm going to talk about some of the contributions that the Arabic culture contributed to math. They made contributions to the following: arithmetic, geometry, algebra, mathematical logic, general mathematics, and trigonometry. They have big staples in all of those areas of mathematics. First, I'm going to start with arithmetic. They pretty much set up our number system. Again, they introduced negative numbers. They talked about zero as a real number. They did binary numeral system. They included infinity, the infinity as a number or as the use of a number, showing that it had no end. They talked about irrational numbers, numbers that weren't easily manipulated, and number theory. In geometry, they talked about square roots. They contributed to cube roots. They worked with Pythagorean triples. And they also helped devise Pascal's triangle. And that is within geometry. Here in algebra, which algebra can be manipulated, thought of as a lot of different things. They started with quadratic equations. They used cubic equations, and they also went as far as to teach us how to manipulate quartic equations. And they used all that, they contributed all that into the algebra. Oops. Sorry. Here we go. And trigonometry. In trigonometry, they set staples in trigonometric functions and trigonometric series. Now I'm going to go through and I'm going to talk about a few number systems. The few number systems I'm going to talk about, we're going to talk about the Egyptian, the Babylonian, Chinese, the Mayan, Aztec, Arabic, and the Indian, all of these number systems. I'm just going to give you a brief description, and we're going to talk about how each one kind of maybe influenced the other one. All right, the Egyptians, they had a number system using symbols and hieroglyphics, and hieroglyphics are just another word for symbols to represent different place values. For the number 1, they use a single stroke. For the number 10 is represented by a hobble for cattle, which is just an upside down U. 100 was a piece of coiled rope, and I don't know if you can see that, that's right there. 1,000 was represented by a lotus plant. 10,000, a finger. 100,000 was a frog, and 1,000,000 was a god with his hands pointing straight up. They used all these symbols to write down numbers and to actually count out the numbers, which, you know, versus what we use today is a lot more work. So these are the picture of the symbols right here, and I'm not sure if you can see them real good, but my camera person should be zooming in on that for you right now. Now we're going to move on to the Babylonian number system. The Babylonian number system, like the Egyptians, the Babylonians had a number system based on symbols. Their number system was used a base 60 instead of a base 10 like we use today. And using that base 60 probably was pretty difficult for them to manipulate. Probably why they kind of just stopped at 60. Right here, as you can see, the number 1, or each individual number, each character is kind of represented by like a Y with a little line on top for each one digit. So we have 1, then we have 2, 3, and as you can see, they just had the 3 and they just piled them on top of each other. It kept them in an order. Once you got the 9, it turns into a sideways A, and it turned that represented the number 10. And as you can see, as we go through 11, it's sideways 10, which is 10, but plus 1. So that ended up with 11. We go on and we have 2 of the sideways A's, which is 20, go on to 30, 40, 50. But at 59, they stop and they start a whole new row on to the next one. So they would have this. They would take and stop, and they would just have the numbers off to the side and then start all over with the 1s, 2s, 3s. And that is the Babylonian number system. Here I have the Chinese number system, another system that again uses symbols They have symbols that corresponded with 1 through 9, and then they have a number system that we use special characters for 10, 100, 1,000, 10,000, 100,000, all multiples of 10. So each time they would change to a different symbol. 1 is pretty basic. 1, 2 strokes for 2, 3 strokes for 3. And right here is where it starts getting a little bit more difficult, where they start actually using symbols, and it doesn't really have, I guess to me, the same kind of meaning as, the 1, 2, 3. But right here, we get to 10, 100, 1,000, 10,000, million to million. Each time we went more and more. For every multiple of 10, there's a different character. And that is the Chinese number system. Up next, we have the Mayan number system. I thought this one was pretty neat. It was pretty simple and easy to follow. The Mayans used a number system with a base of 20. They only had 3 symbols, which is the shell right here. Then they had a dot for each digit in the ones place, and then a line for 5. So once you got the 4, you stopped and replaced it with a line. Like you have here, we have a line and 6, so it's like 5 plus 1, which gives you 6. So theirs was based on a base 20. Once you got to 20, well, let's go through 19. Let's start. 19, we have 4 dots for 4, 5, 10, 15. 15 plus 4 gave you 19. And then you see here, we have our little shell symbol again, which is our 0. But we have 1 dot at the top. That shell and the 1 dot at the top indicated that we have a base 20. So that's 20 plus 0. So now I have my base 20 at the top, and then plus 1, which gives me 21. My base 20 at the top, and my 2 dots at the bottom gives me 22, and so on and so on. This one's pretty easy, pretty neat to follow. Still would take a whole lot of writing, unnecessary work, which is not as easy as the number system that we deal with today. Here we have the Aztec number system. Like the Mayans, it is also a base 20. Theirs was pretty similar for the fact they use dots and lines in there to express their numbers. But as you can see, once you get to 20, it starts changing to different symbols. So you have a flag. If you wanted to say 80, you would have 4 flags, 20, 20, 20. And once you got to 100, you would draw the little, to me it looks like a half of a leaf or a quarter of a leaf. Once we got to 200, we draw the leaves on the other side, 300, and then 400 will fill up the whole leaf. Or you can draw this symbol right here. Once you got to 8,000 though, it became this trophy type of symbol. I wasn't really sure why they went from 400 to 800, but it was just a little bit different than all the other ones that I kind of looked at. And that is our Aztec number system. The next number system, I'm going to go into a little bit more detail. It's the Hindu Arabic. No, we're supposed to do Arabic and we're supposed to do Indian, but the Indian and the Arabic were so similar, I combined them into one. And that is the Hindu Arabic number system, which is the number system we pretty much use today. The Hindu Arabic number system is based on place value. So you have like a 1, 10s, 100s, 1,000 spot. The numbers are the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the numbers that we use today. And those symbols are called glyphs, not just numbers. Today, the Hindu Arabic numerals are the most commonly used symbolic representation of numbers in the world. And as I have up here, it's just a little, just want to show you how it evolved over the years. And we start with the Brahmi, where it has nothing because 0 wasn't recognized. So they had nothing there for the place value of 0. And so you have a line, a stroke line, stroke line, stroke line. Then we kind of start getting different with 4. But as we go down, as you can see, the numbers start evolving. Hindu is 0. That kind of, there's 0 kind of came into play. Got a little different kind of squiggle for 1, but then you can see the 2 and the 3, kind of the 4, and how they all start coming together up into the 9. And as we go down, you see how the numbers just evolve into the modern numbers that we use today. So in conclusion, the Arabic culture has given us major contributions to the field of mathematics. Even though they were not given credit for their great accomplishments, they still managed to make a big impact and revolutionize the way we do math today. I'm really glad I got this culture and was able to kind of talk about them a little bit more because I found out a great little